Prove the following identities. Tan of pi over 4 plus a minus tan of pi over 4 minus a is equal to 2 tan of 2a. So just focusing on the left hand side for the moment. So tan of pi over 4 plus a minus tan of pi over 4 minus a. So we want to have a look on page 14 of our formula tables and see if we can see a formula that looks similar to each of these. So one of our formulas is tan of a plus b is equal to tan of a plus tan of b divided by 1 minus tan of a tan of b. So tan of a plus b is very similar to tan of pi over 4 plus a. So it's basically tan of something plus something, tan of something plus something. So we're going to let the a in our formula be pi over 4 and let the b in our formula be a. So then on the right hand side of the equal sign, everywhere we see an a, we swap for pi over 4, and everywhere we see a b, we swap for a. So tan of a becomes tan of pi, we bring over the plus, and tan of b becomes tan of a. And that's divided by 1 minus, so 1 minus tan of a, so tan of pi over 4, tan of b, tan of a. So this becomes this, and then we bring down the minus. Next we have tan of something minus something. So we're going to use the formula tan of a minus b, and that's equal to tan of a minus tan of b divided by 1 plus tan of a tan of b. We're going to let the pi over 4 represent the a and the a represent the b. So everywhere we see an a in our formula, we swap for pi over 4, and everywhere we see a b in our formula, we swap for a. So tan of a becomes tan of pi over 4, we bring over the minus, tan of b becomes tan of a. That's divided by 1 plus tan of a, which becomes tan of pi over 4, tan of b, which becomes tan of a. So this becomes this. Now we can start to simplify. Well, we notice that we have tan of pi over 4 in each of our fractions. So tan of pi over 4 and tan of pi over 4 cancel. So we're left with 1 plus tan of a. So 1 plus tan of a, because tan of pi over 4 divided by tan of pi over 4 is 1. And then we have 1 minus 1 times tan of a, which is just 1 minus tan of a. So this simplifies to this. We bring down the minus. Tan of pi over 4 and tan of pi over 4 cancels, so we're left with 1 minus tan of a for our numerator. And on the denominator, 1 plus 1 times tan of a, which is 1 plus tan of a. So this becomes this. So we're left with two fractions. Technically they're algebraic fractions, and we want to subtract them, so we have to find a common denominator. So we're going to stick the 1 minus tan of a onto the 1 plus tan of a with brackets around it. So 1 minus tan of a divides into the denominator, cancels out with the 1 minus tan of a, and we're left with 1 plus tan of a, which we multiply the numerator by. So we get 1 plus tan of a multiplied by 1 plus tan of a is 1 plus tan of a squared. We bring down the minus. We do the same on the other side. 1 plus tan of a and 1 plus tan of a cancels, leaving us with 1 minus tan of a, which we multiply the numerator by. So it's 1 minus tan of a multiplied by 1 minus tan of a is 1 minus tan of a squared. Next we can multiply out our brackets. 1 plus tan of a squared gives us 1 plus 2 tan of a plus tan of a squared. Bring down the minus. And 1 minus tan of a squared gives us 1 minus 2 tan of a plus tan squared a. We can simplify a bit more. 1 minus 1 will cancel, and tan squared a minus tan squared a will cancel, leaving us with 2 tan of a minus 2 tan of a, which is 2 tan of a plus 2 tan of a, which is 4 tan of a, and that's still all over 1 minus tan squared a. And the rough work for that is on the next slide. So we have 4 tan of a divided by 1 minus tan squared a. Now if we look in our formula tables, we see a formula that looks very like this, and it is tan of 2a is equal to 2 tan of a divided by 1 minus tan squared a. So instead of a 2, we actually have a 4. But we can factorize and take out the 2. So 2 into 4 goes twice. So 2 multiplied by 2 tan of A is 4 tan of A. So now inside the brackets we have a expression that matches up with this formula exactly. So we have 2 tan of A as our numerator and 1 minus tan squared A as our denominator. So this is equal to tan of 2A. So this is equal to tan of 2A. We have to bring down the 2 in front as well. So we end up with 2 tan of 2A, and that's what we were asked to prove. So this is the rough work for 1 minus tan of A squared minus 1 minus tan of A squared. So 1 plus tan of A squared becomes 1 plus tan of A times 1 plus tan of A. We bring down the minus. And 1 minus tan of A squared is 1 minus tan of A times 1 minus tan of A. So breaking open the first bracket, we bring down the 1, stick on the second bracket, 1 plus tan of A, bring down the tan of A, stick on the second bracket, 1 plus tan of A. 1 by 1 is 1, 1 by tan of A is tan of A, tan of A by 1 is tan of A, tan of A by tan of A is tan squared A. Bring down the 1, tan of A plus tan of A is 2 tan of A, bring down the plus tan squared A. Next we're going to work out this binomial. So we have 1 coming down here, and then we stick on the second bracket. Then we bring down the minus tan of A and stick on the second bracket again. 1 by 1 is 1, 1 by minus tan of A is minus tan of A, minus tan of A by 1 is minus tan of A, minus tan of A by minus tan of A is plus tan squared A. Bring down the 1. Minus tan of A is minus 2 tan of A, and tan squared A just comes down. Now remember there's a minus stuck on in front. So the 1 and the minus 1 will cancel, and the tan squared A and the minus tan squared A will cancel, leaving us with 2 tan of A minus minus 2 tan of A, which is 2 tan of A plus 2 tan of A, which is 4 tan of A. Then the denominator. So we have 1 minus tan of A multiplied by 1 plus tan of A. So again, we break open the first bracket, bring down the 1, stick on the second bracket, bring down the minus tan of A, stick on the second bracket. 1 by 1 is 1, 1 by tan of A is tan of A, minus tan of A by 1 is minus tan of A, minus tan of A by plus tan of A is minus tan squared A. Bring down the 1, tan of A and minus tan of A cancel, bring down the minus tan squared A.